For this lab, you're going to want an 8.5 by 11 sheet of paper. It can have lines on it or not lines, it doesn't matter. You want something to write with, either a pen or a pencil, and then you'll need some kind of a stopwatch, whether it's on your phone, whether it's online. And you'll also need a ruler. If you don't have a ruler at home, then you can go online and there are digital rulers you could use from there.
Good.
Okay, so on your sheet, you're going to want to draw a straight line across. That's going to be our wave at rest. And whenever you draw the wave, we're going to hit start on the stopwatch. So I'm going to start the watch and start drawing. Now, it doesn't matter how much of the wave you draw, as long as you end it the same way you started, like you have a complete wave. So since I started going up, I'm going to end going up, and then I'm going to stop the stopwatch at that point. Now that you have your wave, there are a couple different things that we can talk about with the wave properties. So remember the peaks of this, these are all our crests. The ones at the bottoms or the low points, they are all our troughs. And however far away the wave went from that center point, so from the center up to the top or from the center down to the bottom, those are what we would call the amplitudes, the amplitude. And then one wavelength is one complete up and down. So right there, that's one wavelength. This up and down, that would be my second wave, my third wave, and my fourth wave. Now we're going to find the velocity of the waves two different ways. The first way we're going to do old school is our displacement equals velocity times time. And then the second way that we'll do it is the new way, that is with waves, where the velocity is the frequency times the wavelength. So to go with the old one, what we're going to do is measure our distance of the wave. So take your ruler. If it measures in centimeters or meters, I'm going to go with the 16 centimeters here, which is going to be the same as 0.16 meters. If you have to measure that in inches, measure it in inches and just convert it. And if you don't know how to convert it, use one of the Google converters. Also, if you remember, I have the time for that. My time from earlier was 11.03, so I can plug that into the equation. 0.16 equals a velocity times 11.03, and I end up with a velocity of 0.0145 meters per second. So that's the velocity that I have using displacement and time. Now, the second way is we're going to do velocity is frequency times wavelength. So if you remember, the frequency is 1 over the period. Now, when we measured this wave, we have a total distance of 0.16 meters and a total time of 11.03 seconds. But when we talk about frequency and when we talk about wavelength, we really only want the time and the distance for this first wave. So what I'm going to have to do is I'm going to have to take the total time and divide it by the number of waves that I have. So in my case, it's 4. In your case, maybe it's 3.5. It might be 3. It might be 2.5. However many of the waves that you have. So I'm going to take and say that my period is 11.03 divided by 4, and that is going to be a period of 2.7573. So to find the frequency, then I'll take and do 1 over 2.7573, which gives me a frequency of 0.36267. To find the wavelength, I'm going to do the exact same thing, only with the distance. So my wavelength is going to be the total distance divided by the number of waves that I have, which was 4. So I'm going to take 0.16 divided by 4, and that's going to give me a wavelength of 0.04. So 0.04. Now, when I do this frequency times wavelength to get my velocity, I'm going to have 0.36267 times a wavelength of 0.04, and that gives me a velocity of 0.0145 meters per second. And then notice the next question on your lab sheet is going to say to compare those two, and you'll notice that they should come out to be the same. The last thing we want to talk about are some of the different things of where this comes from. So if you picture my hand as being the source of the wave as it was going back and forth, so the source is going to be my hand or the pencil or my arm, and then the paper is going to be the medium. So if my hand is sitting still and the paper is moving through it, then the wave is moving through the medium of the paper. So the medium is going to be the paper. What we want to talk about then is, where does the energy for the wave come from? And the energy is told in the amplitude. And so when I talk about the amplitude is coming from my hand not the paper. So it comes from the source. If we want to talk about then the velocity of the wave, how fast is the wave moving? Wasn't that dependent on how quickly the paper would move underneath my hand? So the velocity is going to be by the medium, which is the paper. And then the last thing we talk about is the frequency. So how often does the wave go up and down? Is that dependent on the paper or is that dependent on my hand? And we would say that that is dependent on the hand, which in this case is going to be the source. So when we talk about the different properties of the wave, we can say what causes those properties. The energy, which is the amplitude, is going to be caused by the hand, which is the source. The velocity is going to be caused by the medium. So if you think of like a foggy day, the velocity of the wave is going to be very different for a foghorn than it would be on a very clear day. So the medium in this case was the paper. And then if we talk about the frequency, the hand, it's how quickly the hand is going back and forth. The source of it is what causes the frequency.